Let's discuss how to develop solution for the k-nights problem. So what is k-nights? It is very much similar to the n queens problem. So in n queens problem we have to place n queens on a chessboard so that no queen attack each other. Similar to that we have k-knight problem where we have to place k knights on a chessboard so that no knight attack each other. So here we can have a chessboard of different sizes. So it is not necessary to have chessboard of having size of 8 by 8. So we will take input the size of chessboard as m into n. So it could be anything. It could be 3 by 4 as well. So we will discuss that how to develop solution to place k knights on such a chessboard. Now to develop a solution we need to understand how the knight attack. So attacking of knight can be seen if a knight is placed, let's say if knight is placed here. So now each knight can attack at 8 different positions. So it can attack here, at this place, at this place, here, similarly on other sides. So one knight can attack the 8 positions. So if you know the position of knight, whether it is at I and j, so if you know that how the value of I and j changes in your matrix. So if I is the number of rows and j is the columns, so if you know the I and j, you can find out the position of each of these attacking positions. So here it is 2 row above and 1 column behind. So this is I minus 2 j minus 1. Similarly, this is 1 row above and 2 column behind. So this is I minus 1 and j minus 2. Similarly for this is 2 row above but 1 column ahead. Similarly for this one, I minus 1 because it is 1 row above and 2 column ahead. So similarly, once you know that where the knight is placed, you can easily find out all the attacking positions. So one function that you have to develop is, you can name it as attack, and you will pass on the board and you will say that okay, I want to place my knight, or I have placed my knight on I and j position. So let's mark all the attacking positions. So this function will mark all the 8 position where a knight can attack. But you have to make sure that those positions are on the board. It might be possible that knight is at the one side of the chessboard. So some of the position may go outside the chessboard. So you have to be careful not to mark those positions. You have to mark only those positions which are on the chessboard. So this is the first function that you have to make. Another function that you have to make is the place function, to place your knight, and you will pass on the board. You will place a knight on I and j, and it will return the another board. So it will place the knight and it will return the board back to you. So another function that you have to make is the can place, just to check whether you can place a knight on that position or not. So again you will call the pass on the board and I and j. So it is just a binary function. It will return 0 or 1. So 0 means you cannot place, 1 means you can place. So if you can place, then you have to place a knight. So this function just checks whether the board is empty and it is not attacked. So whenever we start developing solution, we will initialize the board and with all zeros, So size of chessboard depends upon the user. You will get the size of chessboard from the user. It could be of size m into n. You will get an array of this size, and then you will initialize the chessboard with 0. Whenever you place a knight, you can mark that position as 1, and whenever you mark the attacking position, you can mark that position as 2. So can place function is just checking that if that position is 0, it means there is no knight and there is no one attacking, so we can place there. So it will return true in that case. So these are the three functions that you have to make before coming to the main solution. Now we know that the main solution, we know that in the n queen problem, so we have used the backtracking to solve this problem. So we will also use the backtracking method to solve this problem. So we will make a function which will be a recursive function. So let's name that as a kn, and in this function you have to pass on the board for which you want to develop a solution. Now this board is initialized in the main function, and size of chessboard is also taken in the main function. It is initialized and then passed on to this function. Then this function requires that how many knights to be placed. Again, this value you have to take it from the user, because so that to make your solution robust, you are taking the size of chessboard and the number of knights to be placed. Then the starting position from where you want to start placing these knights, and the end position where starting position in both I and j. So both these values you need. Obviously in the first case these will be 0 0. When you start the solution, the main function would like to start placing the board knights from the 0 0. So in the first call, so these two will be value 0 and 0. Now we are making a backtracking solution and a recursive solution. So first of all we will write the exit condition. So if k is equal to 0, that is there is no knight to be displayed, no knight to be placed, so it means we must stop the function because there is no knight to be placed. So what we can do is we can display the board. So since this is a two-dimensional function, you can display the board so that it can easily interpretable by the humans. At most you can also count the number of times the board is displayed. You can have a counter here, a static integer counter, so that can also be print out, or you can you can display that as well, that okay, this is a number 1 board, this is a number 2 board. So these two lines you can kept here. So if this recursive condition is not true, it means there are knights to be placed. So in the else, then we will start our rest of the backtracking solution. Now in the else we will start the loop for I. We start from sti. Sti is coming from the function to m minus 1. We are assuming that our board start from 0 and 0. So size of chessboard is mn, so we will loop to m minus 1. Then inside this we will have another loop, because it is two-dimensional that we are considering, to n minus 1. So now in these two loops, so it means that we are not able to access the board array one by one from 0 0 to we are accessing each element in these two loops one by one using the value of I and j. So if we can place the same function that we have discussed, if we can place on the board the value of I and j we will pass on. If it can be placed, so it means then obviously we have to place. So but before placing we will allocate a new board. So allocate new board means we have to allocate a new memory. The board which is passed on to this function, it has to be separate from the new board. So you have to allocate the new board memory, either using, if you are using C you can use malloc, or if you are using C++ you can use the new to allocate memory of the same size of the board. So you have to allocate a new board. Now this new board, we know that when we call the place function it returns a new board, so we have to assign that to this. So we have to place on the board, so this board is a previous board, so which actually is passed on to this function, and now the new board. So here the place function will place the I and night on I and j and generate a new board. Inside the place function we will also call the attack function, where we will mark all the attacking positions. After doing so, now we know that we have placed one knight, but we have a task of placing the rest of the knights. So we will call the same function new board, but now we have to place only k-1 knights and starting from I and j position. So there are three lines in this code: allocate new board, and then calling the same function again. So here the recursion happens, but when we call we are sending the new board. Now we are reducing the value of k so that eventually this exit criteria met, and then it will be finally placed. So there are only three lines in this if condition. After that new call will be given to the new function, and when it returns back our this if condition completes, then this j loop will complete. So this is the ending of j loop. After ending of j loop, before starting of I loop, we will initialize the j to 0, so that next time the j start from 0 again, because for column we again want to start from the 0 again. Then we end the I loop, and then the else, and then the main function, kn function. So in this way this whole function will complete. Now to understand whether it works or not, so this looks very simple, whether it works or not, let's trace it out on a very small chessboard. So I have written the same function here, so for your reference. Let's say from the main function, so main function we got the chessboard of size m is equal to 3, n is equal to 3, that is size of chessboard is 3 by 3, and we are given a task to place 3 knights on this. So I am taking a smaller example for understanding. So main function will create a board which is empty and of size 3 by 3. It will call the this function, and this board will be passed on. We have to place 3 knights, so k's value is 3, and we have to start from 0 and 0. So remember, STIK and STJ is the from where we have to start. So this board is given. Let's call this as kn1 just for understanding that this is the first call. So even though the names are same, so just for understanding we are calling it as kn1. So in this function the first line, if k is equal to 0, obviously this is false. We come to else. In the else we will start the loops from I is equal to 0 to 2, from j is equal to 0 to 2, and obviously we can place it in the first position. We can place the knight, we allocate the new board, and a new board will be created. So whenever the new board is created, then we call the place function because we can place it. So we have placed one knight here. Inside the place function we also mark the attacking positions. So knight is placed and all the attacking positions are marked. So after that again the call to the kn goes. Now this call is the second call. I am just writing 2 here just to for understanding that this is second call. It will get this board, and now k minus 1. The 2 knights have to be placed because we are reducing the value of k, and start from 0 and 0. Now in this function also, since k is not 0, we come to else part. So loop start from I is equal to 0 to 2, j loop start from 0 to 2, and now can place board 0 0. We cannot place it because there is already a knight there. So when we, if is false, it means j increments. So j loop increments. So j loop increments means now j's value is 1. So again inside this, if we can place board 0 1, so this place is empty. Obviously we can place it. We allocate a new board. So whenever we allocate a new board, we copy it from the previous board all the positions. So all the positions are copied, and the new knight is also placed. So these positions which are there in the previous board, they are copied, new knight is placed, and new attacking positions are marked based on the new knight. So this is the configuration after the placing 2 knights. But after that we again give call to the kn again. Now this is the third call. For this is the board. Number of knight to be placed is 1. Value of I is 0. Value of j is 1. This is the last value where we have placed the knight. So these values are given to this board. Again, since value of k is 1, so we will come to else part, and from I 0 to 2, because value of HTI is 0, j is 1 to 2, because value of HTJ is 1, and again we check, can we place board, this is the board, at position 0 1, but we cannot place because there is already a knight there. Increment the j becomes 2. Again we check, can we place at board 0 2. So we can place it here because this is empty position. So we allocate a new board. So a new board is created. We copy all the previous positions. So all the attacking positions are also copied. And now we can place the third knight, and its new attacking position is also marked. So we have now placed the 3 knights which are not attacking to each other, and after placing it, now we call the Kn4. So Kn4, this board is given K minus 1 is 0, value of I is 0, value of J is 2. Now in this case, in the Kn4, since the value of K is 0, so it will display this board. So this board will be displayed. This is the first board that gets displayed, and it is the correct board because there are 3 knights and no knight is attacking each other. So after displaying, we can, as I said, we can also count, we can put a counter here, and then it returns back because everything is in else. So here the function Kn4 completes. It returns back to Kn3. Now Kn3, which in the previous case generated this board, now again the loop start. So it comes here, J loop ends because it started from 0 to, now I loop increment, I becomes 1 and J becomes 0. We are making J 0 here, so that whenever I has to be incremented, before that we are making J 0. So J becomes 0. So we are now checking at 1 0. So remember, for this function Kn3, this is a board, and it is checking, whenever it is checking the board, it is checking in this board. So again we can place here because this is empty position. So a new board will be created from the board, but this time different from the previous one. First we copy all the positions which were marked there. Now we will place, now new knight, it will be placed here instead of that because our loop is at 1 0. So third knight is placed here. In the previous case, third knight was placed here. Again, after placing a knight, we call the Kn4 again, and fourth call by passing this board. Previous time we passed that board, now this board. Again value 0. Remember, the value of K minus K value is 1 in the Kn3. It is only becoming 0 in the fourth call. This time value of I is 1, value of J is 0. Now in this course call as well, since value of K is 0, so this board will be displayed. This is the second board. So this was the first board displayed, this is the second board displayed. Again both are correct because here again 3 knights are placed. After that Kn4 again return back to Kn3, and Kn3, since there is loop, it will again increment. Now it increment to 1 comma 1. Again we can place a new knight there, a new board will be generated, and we will copy all the previous positions, and now in this case the knight will be placed at this position, and the Kn4 is again called by this board. Now Kn minus 1 is 0. We have I and J value 1 and comma 1, and again this board will be displayed. So this is the third configuration. So this is the third way to place 3 knights on the 3x3 chessboard. Again Kn4 return back to Kn3. Kn3's loop again incremented to 1 comma 2. Can place false because it is attacking position. I increments now, J becomes 0, 2 comma 0 we cannot place, 2 comma 1 we cannot place, 2 comma 2 we cannot place because all are attacking positions. So eventually Kn3 will end. When Kn3 end, it goes back to kn2, the second recursive call. So it backtrack to that position. So kn2 is responsible for placing the second knight. Previous case it placed the second knight here. So it has a board this is the board available to kn2. Now kn2 again try to place the board. Its loop was at 0-1. When it placed the previous knight, its loop was at I0 J1. Now loop increment, I0 and J becomes 2. So it generates another board, new board, by first copying its board. This time it places knight here. Previous case it placed the second knight here. This time it plays the second knight here and it calls the kn3 again by giving this board value of, it knows the k is 2, so k minus 1 is 1 and value of I 0 and value of j is 2. So we can see that the kn2 plays the second knight and call the kn3. From there onwards kn3 start checks. The relevance of giving these value sti and sj is we have to start looking from there onwards from where the last knight was placed, not to the previous board places. Otherwise your same configuration will get repeated. In this case same configuration won't get repeated. We will get another board for kn4 where third knight is placed here. So which is very different from the, when we placed here attack comes here. So this is also attacking. We have to also mark the attacking position. So we won't be able to place here. So we will place here. So this is the call given to kn4. So we can see that whenever call to kn3 goes after placing the second knight, kn2 plays the second knight and call goes to the kn3. The duty of kn3 is to place the third knight from there onwards if it is possible, and then it calls the kn4 to display the board. So in this way the whole process will goes on. So kn2 will keep on changing the second knight. Accordingly the third knight's position will also get changed and new configuration will keep on coming up. And once a kn2 ends, then kn1 whose duty was to place the first knight. First time it placed here, then next time it will place to the second position and accordingly call the kn2. So that will be a separate branch in that, where kn2 will place the second knights accordingly and then kn3 will place and so on. So if we follow this procedure we will get all the configurations. So for effective implementation what you need to do is, in the main function get size of the board. For initial you can get a smaller board to test your function, number of knights, and then call this function. So it will display all the configuration. You have to just make sure that if you want to count you can put count here. You can put count here, and this way you can also count the number of configurations. So I hope you will be able to implement with this discussion. So thank you very much.